everyone, and welcome to Supercharge or GraphQL with Ktor and GraalVM. I'm Derek from Apollo, and I'll be your host for the next 30 to 40 minutes. Today, I'm going to try to do some live coding to show you how easy it is to create a Ktor GraphQL application. But before we get to the coding part, we're going to do some refresher on some of the technologies that we're going to be using today, right? So without further ado, let's talk about GraphQL. So GraphQL is a query language for APIs and a runtime to execute those requests, right? It is a specification that defines how to expose your data in a certain way, such that the clients can easily discover it and selectively ask for the data they want and only for the data they want. At the heart of a GraphQL server lies a schema, which is strongly typed. Schema defines all available operations and types that the clients can access. And starting from the root operation types as read-only queries or update mutations, each field has to define a very specific type in it, right? So the fields have to resolve to either primitive values, such as strings or integers. They can reference an enum value. They can reference complex types that has a number of fields on it. Or they can also use a list of any of those types. GraphQL also is null-aware, meaning that it makes a distinction between nullable fields and non-nullable fields, and you have to declare it when you're building the schema. These non-null constraints are actually enforced at runtime. So if you define a field that is not nullable, it is guaranteed that the clients will always get it. If you cannot resolve that field, it's going to result in a server error. On the flip side, if you have a nullable fields, and you cannot resolve it on the server, clients can still get all the other data, and they can get like a partial response back and still make something useful out of it. And last but not least, GraphQL also supports polymorphism through the means of interfaces and unions. So interfaces define some common traits or fields that all the implementing types have to share, and unions are just a disjoint collection of all the types, right? So, but how does it actually look like in practice? So hopefully this is readable. But on the left, we have like an example of a schema that we're going to try to implement today. You can see it's actually human readable. You have fairly easy to understand. You have some types, there's some fields, they have the types associated with them. At the end of the type declaration, you have exclamation marks that they actually define that the field is nullable or not, but it's very easy to actually understand what's happening, right? Clients then use this information to craft the queries, which we can see an example in the middle here, right? And once they send it to the server responds with the data that matches exactly our request. And you can see an example here on the right. This allows you to build a very flexible APIs that fulfills a number of different needs, right? So very common use case is that you don't have a single client, you have multiple clients, right? So you have mobile apps, you have some web apps, right? And you do want to share some common data between them, right? So you want to share same experience. So the common set of data that they both request is the same. But on the desktop, well, you have a larger screen, so you can display more data. You have a faster connection, so you can fetch more data without much of an impact. So you can actually create a much bigger query that actually gets everything at once that it needs to provide a better user experience, right? And another interesting thing that you may notice here is that in a single GraphQL request, I'm actually asking for multiple queries at once. So I'm fetching the conference data, I'm fetching some people data, I'm fetching schedule data as well, right? So if we compare it to traditional REST-based APIs, right? In REST, we deal with resources that are predefined, have a predefined structure through the means of URLs. And those, like 3 different queries, they probably would correspond to separate endpoints, right? You may say, I can create something that produces the same thing in REST. Sure you can. But the difference is, it's not really flexible. So if you create those custom tailor endpoints for your applications, well, that's the pattern called BFF, or backend for frontend. The problem arises there if you have multiple clients, right? So as I mentioned, you have different needs for your mobile versus desktop. So then you create a BFF for your web and native apps, right? And then what happens next? You want to support a watch, right? That's another BFF. Then you want to support some voice assistants like Alexa, makes another BFF, right? Do you want to create another one for some like streaming devices like Roku or whatever? It's basically this pattern doesn't scale at a certain point. If you don't create those custom endpoints in REST, well, you end up, okay, I can give you this data and just deal with it, right? The problem here, so your mobile clients may not necessarily need all of this data, right? So for desktop, it can be perfectly fine, but the mobile is going to throw away half of it, right? So you overfetching the data again, which leads to inefficiencies as well. So in those different scenarios, GraphQL is a very powerful utility to build those all flexible APIs. And another interesting piece about it is that with GraphQL, since it's very explicit what client asks for, we know what fields are actually being used in our schema, right? So we can evolve our schema without breaking any clients. If we introduce a new field, well, no one is asking for it yet, no one is broken. If we want to deprecate some fields and remove it from our schema, we can actually let that information inside of the schema saying, hey, this field is deprecated, I'm going to remove it. And if you're using some type-safe clients like Apollo client, you can actually configure it to fail at build time, saying, hey, you're using deprecated field. Don't use it anymore. Fix it, right? So it's very powerful utility. But then, since you know which fields are being requested, if no one's using those fields, you can also drop the parts of your schema that no one's using, and again, not breaking any clients. It's a very powerful pattern to have a versionless APIs that fulfills all those different use cases. So today we're also going to be using Ktor, which is a lightweight web framework from JetBrains, right? It's written purely in Kotlin, comes with first-class support for coroutines, which allows you to build those fully asynchronous web applications using imperative style, right? Which is easier to reason about. We all love coroutines, they're great. But what's also great about Ktor is that it's actually very easy to pick up and understand because it follows the functional configuration style. There's no automagical wiring of the beans behind the scenes, so there's not something that's going to pop up based on the something that's on your class path or whatever, right? Here you have to explicitly opt into some functionality. You have to explicitly configure your plugins, add the functionality to add it there, which means it's very easy for new people joining your team to actually see what the application does. There's no magic behind it. And last but not least, we're also going to be using GraphQL Kotlin, which is a collection of libraries that help you run GraphQL in Kotlin. There are a number of modules there. Today we're going to be using a couple of them, starting with a schema generation module, which, as the name implies, helps you generate the schema. So we're going to be using reflections to generate the code, the GraphQL schema directly from your code, meaning that you can write your functions returning data classes, and it's going to automagically, which we may not like, it's going to automagically create a corresponding GraphQL schema and match the resolvers to your function. So you don't have to do any of that boilerplate code. It's taken care of for you. And I'm also happy to announce that with the V7 of GraphQL Kotlin, now we officially support Ktor as well. So we have a Ktor and Spring-based modules to help you run your server, right? So once you have a schema, you still need some boilerplate code around how you process the incoming request, how you initialize your schema, how you actually invoke the engine, right? It's a lot of boilerplate code, so you can use the pre-built modules that help you do that. But enough talking. Let's do some coding, right? So I actually, in this repo, there's already the demo application that I've added in. And let's try some coding. So in the interest of time, I already preloaded it in my IDE. So, but it's actually generated from Ktor generator, startktor.io. The only difference is that I chose a CIO engine. And the only modification that I did over here is actually I bumped the Gradle version because I want to use Java 19. So looking at our build file is actually very simple. So by default, it pulls Ktor core JVM. We're actually going to replace that, because it's a transit dependency, with Gradle server plugin, actually, server library. So you can see I'm using alpha here, so don't get scared. We're still finalizing the final release, but so it's work in progress, but it's fairly stable. I don't expect many major changes there. So with this, we can reload it and start coding our server. So let's open application. So this is what was generated by Ktor. We don't need the hello world routing module there. Instead, let's create some query. Instead of hello world query, we can create a conference query. Conference query, and we need to implement this marker interface from the library. There's nothing in it, it's just a marker, so we can actually find it easily using some of the tooling later. So with the conference query, now we can actually create a conference actual operation that the clients can interact, right? So once you have a class, we can say we want to do a conference. That's going to return us a conference. So let's create a data class that's going to match it. So we got data class conference, right? And let's do some stuff like conference is going to have a name, right? Let's make it a string. And conference generally have some location, right? So let's do location also. So we can just return this data class over here with the Kotlin conf and Amsterdam, right? So we have our query. Now we need to configure our GraphQL server, right? So using Ktor, we have to install the new plugin from GraphQL Kotlin and configure our schema. Since we are using reflections to generate the classes, and we need to look up what are the type hierarchies are there. We don't want to scan the whole world. We need to specify what are the valid packages that we actually accept. So in our example here, we just want to do com example. And last but not least, we have to specify the queries that we want to use. So again, this is a list of queries, and we got our conference query. So now if we start up the application, it's actually not going to work because I forgot about one thing. We also need the routing there, because how do you actually want to accept a request? So we need to configure the routing. So let's add a routing plugin as well and configure some routes. So we need a post route to accept the post requests. Let's add the graphical route to have an IDE as well. And for convenience, let's also add SDL route to actually see our schema. So now if I restart it, if we try to load up the graphical, this is the IDE from the GraphQL Foundation. There's some alternatives out there like Playground and some other ones, but in general, this allows you to interact with your schema and that craft your queries before putting in your application. So here we can traverse our schema, see what's available. So we had a conference query with location and name, and we can start querying it. So we have a nice autocomplete here. If we try to just run it like that, also does the validation for us. So there's no wildcard queries in GraphQL. You have to explicitly select what you want. So we can specify the fields. So I want to do name and location. And if we run it, you should get the data back. Again, the response matches the requested data. But what's great about the GraphQL as well is that the schemas are self-documenting, right? So we can add some extra documentation there, right? So we can add the GraphQL description saying this is our some description there. And as I mentioned, we can also do communicate that some fields may not be actually used anymore and you should migrate it, right? So let's change the location to actually be nullable. Just so this is actually a breaking change. But if we do that, we can also say that this is actually deprecated. And this will be removed soon, right? So now if I restart it, and reload the schema, there's an interesting that had just happened here. As I mentioned, the deprecation information just gets propagated to the IDE right away. It shows you that this field is actually going to be removed soon. You can see right away, right? If we open up the documentation, We can see that the conference has some description and has some deprecated fields as well. They are hidden by default, right? So it's a very good user experience. But this is like a very basic example. So let's do another query with interfaces. Let's do some polymorphic stuff. So let's define interface people. As far as I know, pretty much everyone should have a name. So let's do that. We have a name. And let's do some implementations there. So we can do data class speaker that implements people. And we need to override the name. And as a speaker, they generally do some talks, right? So let's add some talks. So we get talks, and this is just a list of strings. So let's add another implementation there also, like for the attendees. So let's see. And again, this implements people. We need the name. And just for the heck of it, let's add another field that's going to be different about it. So let's say there's a ticket type, right? So attendees hold tickets, right? So for the, for this exercise, let's assume there are different tickets. So you can have enum class with ticket type. And let's say we have just the conference, the workshop, or the full thing, right? So using this, let's do some fun people, right? So we got fun people. That returns as a list of people, right? And let's just hard code something that's just for the heck of it. So I got a speaker. Let's just going to add myself. GraphQL. And let's add attendees as well. So let's add Alice and Bob. Let's say Alice has full ticket. And Bob has just a conference ticket. So now if I restart it, I reload it, let's take a look at what actually going to show up in our IDE, right? So let's reload it up. And now if I look at it, there's actually going to be a new query here called conference. But the conference is, sorry, not conference, sorry, people. And the people is actually returning as an interface. The only thing that we know about this common interface is a name, right? So, but thankfully, there's actually another utility in GraphQL that allows you to select specific types. So when we're doing the queries, we can say, if it's actually a speaker, I'm going to select also a talks. If I'm actually an attendee, I'm going to select the ticket type. So if we run it here, we get the full response back here with the types that are actually matching as well. So the people, even though it's people returns your interfaces, we have actual types in the response. So with this, so we get a query. For the heck of it, why don't we also do some very simple mutation, right? So let's do conference mutation. That's going to implement a mutation marker interface, and let's do something simple like by tickets. So we can say count how many we want. Let's make it integer, and also the ticket type, right? Let's make it very simple, so just Boolean and say it's true. We need to now add it to our schema here. So we need to specify that we get a mutation is a list of this, right? So we can conference mutation. And it doesn't like something in the code where it doesn't actually like it. Oh, this is not fun. Okay, it's class. Okay. So now if we start it up, we cannot run, while we can run multiple queries in a single request, we cannot mix and match queries and mutation, right? So we have to run a separate request. And here we cannot use the shorthand syntax also, because I haven't talked about it, but this is actually a shorthand for query. Here we have to explicitly specify that this is going to be a mutation, and we do by tickets mutation. So we actually probably should reload the schema first. We got by tickets, and I want to have count 1, and ticket type is full. Right, so if I run it, I get my response back. So again, it's this, whether you're running the queries or mutation, the code is the same. It's just synthetic sugar to tell users that queries are read-only, mutations are create, update, delete. But there's nothing stopping you to do something crazy and do the opposite. So with this, let's take a look also on one more thing, right? So having like the queries that return you static data or whatever, it's not really useful, right? So what we can do here, let's hide this part. We can also have arguments, right? With the functions, take parameters, arguments, so they're actually available also in the schema. So we can say name starts with, right? Make it a string. It's a nullable string. It's optional, and then we can simply filter it. So if name starts with our specified code here. Since it's nullable, I just added a default there that it's an empty string, so it's going to match everything. So if I run it now again and go back to my first query here, now the people query now have an argument there that I can actually pass in, right? So I can specify name starts with D, and I'm just going to get my responses back, right? But there's one thing that we haven't covered yet. There's actually the big implications of how you structure code that on your performance as well. So for that, let's create another a query called schedule, and this is just going to return us a list of talks. All right, so let's create a class talk and add some fields there. So maybe there's going to be some ID. I'm using an ID over here. That's another primitive scalar value from GraphQL. It just means that this is an ID. It's not supposed to be human readable. It's something for your identification there, right? So I can do that. Let's add also maybe a date field, like make it string for now. And maybe let's do a title of the talk, right? Title of the talk, and maybe let's do also like a description or something. And make it optional. So now, if I do it the same way as I used to do before, right? So if I do create my talk, so let's do quickly create a talk here. One second. ID, and I need to generate. Sorry, live coding. Let's pre-fill if something. So the date, I'm from the US, so I'm just going to say in this format. The title is the Supercharge GraphQL, and we don't need a description because it's optional, right? So this is what we've done before, right? We got a data class here. There's nothing wrong with it per se, but it could be problematic. So the clients can selectively ask what they want, right? So they can ask for ID, they can ask for the date, they can ask for the title. They don't have to ask for all of them. So the problem arises, what if, in order to get like the description that is based on a constructor there, I need to make an expensive database call or some backend call, whatever, right? What if that takes like 10 seconds to compute, right? Then if you do it this way, it means that every time you construct your talk object, you have to pre-compute it because it's a constructor value, right? You have to pass that in. So what is the solution for that? Well, it's pretty simple. Instead of having it as a constructor parameter, we can just move it in to a function. So again, it's from the GraphQL perspective, there's going to be exactly the same. And we're going to make it as a string. And for the heck of it, let's also make it slow. So we're going to do something that we shouldn't ever do. So we're going to sleep for 1 second and return something like, okay, we're doing live coding there. So now, as you can probably guess, this is going to be problematic. The sleeping over here, blocking the threads. But that's a spoiler alert. So like if we restart it now and look at our IDE over here, we can now add the schedule query, right? Schedule, and I can do the IDE, I can do the title, description, date, right? So if I run it, it's, now it's going to take a long time because that field is very slow. If I remove the description, well, we expect it to be much, much faster, right? This gets actually even worse. So like what if you have multiple fields there like that? So I can do something here called aliasing to force the same resolution of the same field, but if you have multiple fields that are blocking, they actually responding very slowly, it's going to be problematic. So I can do alias here, I can do another one. So now if I run it, every description field takes a second to resolve. This is going to be very, very slow, right? So the solution to it, well, we're a Kotlin conf, right? So we got to use coroutines, right? So it's as simple as make it suspend fun, right? Instead of the thread blocking, let's do coroutine scope, match it as we add the delay here, right? Same thing, the delay of 1 second. This is lambda, so we don't need a return statement there, right? So if we rerun it, well, it's not as bad as before. It's still slow because that's still like there's the blocking there in 1 second, but it's not as bad as it was before. So, make sure that you're basically trying, whenever you're doing like something that's blocking and slow, just wrap it in some asynchronous code, like coroutines, right? Another thing that you may have noticed, there's actually a date here. So I wrote it in, using, well, it's a hard-coded value, but I wrote it in, US format, right? We're in Europe. That's how people write that, right? So it'd be great to actually have it in a proper, localized format. So obviously, we can actually add like an explicit parameter to it as an argument to a function, but that's not the best user experience, right? So when we're working on web, there's generally, you can pass some headers like accept language, right? So why don't we make it work, right? So in order to do that, we have to initialize what we call a GraphQL context. This is a contextual data for each one of the requests. And in order to do that, we have to create a new class called custom context. Let's do factory, and we need to, for convenience, there's already a default one for Ktor. We just extend it, so we can still use the defaults there. And let's just add our stuff in, right? So we can just add a map of objects there. So let's see, it's a locale to, and for language tag, and we're just going to read it from request, right? So request, headers, and we're going to get accept language. Otherwise, we're going to default to EN US. So with this, we have to still wire it to our schema. There's actually quite a few other options to how you can configure those, but this is going to be actually on the server configuration. So when doing the server, we say this is our context factory, custom context factory, add it in, and now let's try to use it. So obviously, if it's a part of a constructor, it's not going to work because it's actually pre-computed unless we move that logic ahead of time. So let's move this to a function. So instead of this, let's do fun date. So let's create a date format. Short, and we want to get the locale from the user, right? So let's get it in through the context. So we have an option here to get data fetching environment. This is something that's available for all your GraphQL requests, all the data fetchers there. We got to import it. And let's get our locale. So we can get locale. Okay, so we got our format. We pass in the locale, and now we can return a formatted date, right? So let's see if it is going to work. So format, a new date object. Okay, so let's restart it. Oh, too many arguments for a constructor. Oh, okay, sorry. We remove it from here. So if we restart it, then it's just going to run. So now, if I run over the date, I get the same date as I did before, but if I specify my accept language header now, something like maybe French, I'm going to get the different format now based on the user locale, right? So that's all nice and dandy. That's very simple to do, right? But there's actually other use cases that we could cover, but probably everyone's wondering about the other big piece of the that was actually mentioned in the title, right? Talk about GraalVM, right? So let's talk about GraalVM. So GraalVM is a high-performance JDK distribution from Oracle, right? It's based on OpenJDK, and it comes with a full-fledged JVM. So technically, in order to run on GraalVM, you point your application at that JVM and you run it. And actually, we were running on GraalVM all the time, right? Mission accomplished, yeah, awesome, but probably that's what you care about. So there are obviously other great features of GraalVM. One of them is polyglot programming. So that allows you to call other languages from it. So you can call JavaScript, Python, and basically anything that compiles to native code using LLVM compiler, which by itself is a very cool feature. We don't have time to talk about it, just mentioning because I think it's cool, and it's there. What we're going to talk about is the ahead-of-time compilation and ability to create a native image, right? So the question people should be asking is that one of the biggest selling points of Java was write once, run everywhere there's JVM, and JVM is great. It's a great piece of technology. It produces very well optimized code that's super fast, right? But so why would you even bother with native, right? So there are some use cases that JVM is not a great fit, right? So JVM adds a lot of overhead to your application, right? So first of all, from the startup, that's a very heavy process. You gotta the bootstrap process and multiple class loaders have to look at system libraries, your class path, have to link it up, and verify the code is valid. It's actually much more complex than that, but it's a very heavy process that happens in every startup, right? That's why when you start it up, it takes a second or two or whatever long to start it up. And it happens in every time that you run it, right? So if you have like a Lambda, and your code executes in milliseconds, but it takes a minute, like a second to start, well, you're paying for the startup versus the processing time, right? So it's not that great for that environment. Furthermore, right, the code that's produced by JVM is only, it's going to be super fast once it's warmed up. So, but it still doesn't get automatically to that phase. You got to warm it up, right, to do that. So if we do the ahead-of-time compilation, we can actually move this logic to the build time, right, and produce an image that's much faster to start it up. It's going to be much better on memory, etc., right? But again, there's no free lunch. There's always trade-offs. So JVM is very flexible, and we're here moving from runtime complexity of how it actually does the startup, how it actually does all the just-in-time compilation, how it actually does all of this dynamic stuff towards like the build time complexity. And yes, it's gonna make your builds way, way slower. Our very basic app that we were just looking at, right, is gonna add like a minute plus to the build, right, just for that app. So if you have a complex app, it's gonna take much, much longer to do that. But on the other hand, right, you're gonna have pretty much instantaneous startup. You're gonna have like very low memory footprint. The native image is also gonna be smaller, right? But if you're looking at peak performance, well, just-in-time compiler and 20 plus years of JVM still beats it. So if you have a long-running server and you just want to process as much as you can, you want to use the JVM. That's going to be a better fit. But maybe a GraalVM could be a good fit because, starts instantaneously. You don't need to run a base load. Just start your application on the request, right? But the big one is the last piece over here. There's a limitation also from all the dynamic features. So I mentioned that GraphQL Kotlin uses reflections, right, to generate all your code. all that dynamic stuff doesn't play very well with GraalVM, because what you're doing here is instead of looking up at runtime to do all this dynamic stuff, you have to statically compile it, right? So you have to tell it ahead of time. By the way, those are my types, and this is how it's going to work. Which, it's doable, but it's it has its limitations, right? It removes that stuff. So with this, let's see again. Let's convert that application to GraalVM. So we're not gonna. So in order to add the GraalVM native support, well, we gotta do a native plugin, and this is actually allows you to get those tasks to compile it to native stuff, right? The big part of it to make the reflection works is you have to provide this information, right? As mentioned, so you could craft all those nasty JSON files manually, but that's a lot of work. So GraalVM comes with a utility that helps you automate this stuff, right? So you can actually start your JVM app with the agent and generate it automatically, which sounds great until you realize that you have to run every single execution path through your code, right? So every single query that you got to execute it. If you have arguments to it and you don't have arguments, well, those are two different paths, and you have to execute those as well. If you add a new query, you got to rerun it again. Make sure that you update your reflection metadata. It's not such great, right? So instead, what we can do is actually add GraphQL Kotlin plugin, which is going to detect that there is a native plugin, and it's going to actually try to generate you that at build time. So with this, let's load it up. And we gotta do a little bit of configuration here. So first, we gotta configure our GraphQL GraalVM plugin with the list of packages. So again, this is so we know what is available to us and what we can load, right? So we can do that. And we also have to configure, do a little bit of configuration on the native image size. So this is a work in progress. I'm hoping that it's gonna make it simpler than this. But there's a few things over here, right? So the first one is when we're doing this reflection metadata, there's actually quite a few open source libraries that already provide you that for you. There's the GitHub repository that collects all of the data. So like for GraphQL Java or Spring, you can actually point to that one. You don't need to regenerate it. So, but we have to opt in. So that's what you do over here. And there are a few things that we need to add as well over here. So Ktor loves extensions to an extreme. Everything is extension of an extension of an extension, which gets translated to a static methods in Java, right? So we have to statically initialize that at startup. So we have to say that the Ktor packages, there's some Kotlin stuff there, and basically logging, I have to initialize at startup. So we're almost there, but there's one more thing that we have to do. So when we're building our GraphQL schemas, we are using the class path scanning to find out what polymorphic types we got, right? So find out what implementations are there, what are the classes that are implemented. Obviously, class path scanning is not going to work in native image because the jars don't exist. All that information is going to be garbage. So all that information doesn't make any sense anymore. So instead, we have to explicitly tell it what sort of type hierarchy we got. So in our case, we got people class to a list of those two implementations, right? So we got speaker and we got attendee. And that's about it. So let's see. Let's reload our GraphQL Gradle configuration and let's build it. Hopefully, this is going to work. And as I said, this process is going to take a long time. So what GraalVM does, it's actually going to look at your class path, it's going to actually try to trim out all the code that is unnecessary, so unreachable. It's going to do a lot of those precompiled optimizations for you. They're getting better, but it's still pretty slow. So while it's building, we can also take a look at what was generated for us and what you would have to do manually instead, right? So let's hide this stuff for now. So this is the reflection metadata. So generating this by hand is somewhat problematic as well. For some simple cases, it's pretty easy. But you have to remember, like for the conference mutation, right? We are using the non-nullable int, so that actually is a primitive int value in Java. If it's nullable, it should be Java integer box type, right? There's other things there, like if we're using the default stuff, this is actually syntactic method that's generated at runtime, so you have to do that. There's, like if we're using IDs, those are inline value classes that we have to, again, match up. So all of that, those methods there, we have to capture somehow. So using the plugin greatly simplifies that. So looks like it's done, and looks like in a minute. So that was spot on the time. So let's see if it works. No, address already in use. Let's kill that one, let's try it again. And let's allow the connections. So first thing you see, it's actually started in 0.2 seconds, right? It was 0.02 seconds. So that's pretty good improvement over Java, right? So let's make sure that actually works, right? So let's load our graphical again, and if we run it again, it works. Yay, demo's complete. Awesome, it worked. So that's about all what I had for today. Hopefully you enjoyed it. Hopefully you learned something. Please vote, and thanks everyone.
We have a 4-minute slot for questions. If somebody have a question, you can ask. Yeah.
Thank you. I'm actually not sure I understood why you still had to declare inside your code about like the list of implementations of people. Mm-hmm. But the rest was done automatically by the plugin.
Yes.
Why is there this difference?
The difference is because the difference is we actually using a library to scan the class path, and that's the only part that we actually have a dependency on using this great library called ClassGraph that scans it. So that's the only difference there, that this is actually done through a different path of execution. So we need to find out the implementations of the classes, and that's all the other parts, like about reflections. It works fine. So like if you have a reference to all your implementations in your schema, you don't technically need to provide this mapping because it's going to work. It's just that if you return just an interface, then we don't know what's going to be implementation. We have to find out somehow in your class path, which can be in different jars, what are the implementations there.
Thank you.
I'm actually hoping to automate that as well, but it's a work in progress.
Yeah, we have another one.
If you had a custom data fetcher or property resolver for those types, do you have also to configure it specifically when doing GraalVM?
So in general, when using GraphQL Kotlin, you don't need custom data fetchers because your code that actually resolves data is your functions, right? But there's actually a way that you can actually provide your own data fetchers as well if you need to do something else. Like if you need to add like support for monads, which many people maybe not like reactor stuff, right? You can easily do that as well. You can provide that, and it's going to work.
Yeah, we're out of time. Thank you very much. Thank you.